Thank you. Same for us. Nice to meet you.
Do you speak bahasa Indonesia?
Unfortunately not.
No. What about you, Stefan?
I only know selamat datang.
Okay. Selamat datang and terima kasih. How's the temperature in Holland now? Starting summer, I think.
Starting summer, but actually here it's raining at this moment.
Okay. So what about the temperature? Is it already hot or still okay?
Well, for the Netherlands, it's okay. It's like 17, 18 degrees. Yeah, that should be the temperature during this period of time. Maybe a little more, but
yeah, that's good. 17 or 18.
Yeah.
Is it you like in Indonesia at the moment? A bit higher, I guess.
Yeah.
Indonesia right now in Bali. I'm in Bali at the moment. The temperature is 30, 31. Quite hot, but it's okay for us. We are used to it.
Yeah.
But it's good idea to work from Bali right now because the place you can like this. I ran a villa for three bedrooms. It's only like 600 rupiah per day. But if you rent for a month, will cost you like 8 million rupiah per month. It's very, very cheap. Only like less than 500 euro per month with 3 bedrooms. So people can share, 3 people can share the bedroom and then work from here. The internet connection is quite good. So they can do everything, doing programming or whatever, and sending to the company back to Europe or to US. And spending, living expenses here is very, very cheap also. I saw many digital nomad around here.
Yeah.
Yeah, actually Bali is very, very empty right now. Like the beach, the city, it's very empty. Not so many tourists.
So you
actually no international tourists come to Bali. They are not allowed yet. Only local tourists from Indonesia, they come to Bali and spending their time here.
So you got a kind of a private beach then?
Yeah, it's true.
Very nice.
Private beach, private, yeah, many things.
Okay, Mr. Wendy, I think we have to start it now. Can we start it?
Yeah.
Okay. Kita mulai ya, Mbak Jule.
Silakan, Bu.
Okay, baik. Good day, everybody, and good morning for you, Misha and Stefan in the Netherlands there. We will start our Studium General, and first we will start from Mr. Wendy. Mr. Wendy will deliver the opening speech. Please, Mr. Wendy.
Okay, thank you very much. Terima kasih, Bu Rusda, as the head of the study program. Mr. Misha and Mr. Stefan, welcome and thank you very much for your time and opportunity to give a lecture, Studium General, for our student in Indonesia, especially from Universitas Budi Luhur. Most of them from IT study program who will attend this lecture. First, I would like to express my high appreciation for both of you, because from you they will get many information, and I think they will learn a lot from you. I hope this is an opportunity from my student to get information directly from Netherlands, from HZ University, who already cooperate with Universitas Budi Luhur more than 10 years. So I think I hope next year, when the pandemic already gone or maybe already can be controlled, I think we can continue our plan to make more intense cooperation between IT Faculty of Universitas Budi Luhur and IT program, study program from HZ. As the beginning of our cooperation, so this is the very good opportunity for our students from Universitas Budi Luhur students to learn from you anything about what will be delivered in HZ. So I hope they will have interest to join the program and study there. And in contrary, I hope students from HZ also can come to Universitas Budi Luhur, because IT is our main program, in university, beside communication, economic, political science, and social, political science and economic. So please take your time. I hope both of you can come to Indonesia also. It's very fun to come to Indonesia, especially if you can give the lecture from Bali also. Thank you very much. Para mahasiswa yang ikut partisipasi dalam acara kuliah umum ini, saya ucapkan selamat datang dan salam Budi Luhur. Mudah-mudahan apa yang disampaikan oleh para pembicara hari ini bisa bermanfaat bagi Anda semua, dan ambil kesempatan untuk mengembangkan diri sehingga nantinya Anda siap untuk bersaing di manapun, karena Universitas Budi Luhur sendiri punya kerjasama dengan HZ University, dan kita punya program yang namanya pertukaran mahasiswa yang bisa kita selenggarakan, dan kita mendapatkan sebenarnya setiap tahun itu dua orang mahasiswa yang dapat kuota untuk belajar di sana free. Cuman biaya hidupnya yang harus kita tanggung, Anda yang harus tanggung biaya hidup, tapi biaya kuliahnya terus terang cukup besar, yaitu $6.000 sebenarnya, 6.000 euro satu semester. Jadi hampir udah 1 juta lebih lah satu semester uang kuliahnya. Tapi oleh HZ diberikan free dengan konsep yaitu pertukaran mahasiswa. Ambil peluang ini sehingga Anda dapat mengembangkan diri. Terima kasih, selamat berpartisipasi dalam kuliah umum ini, mudah-mudahan banyak manfaatnya. Mohon maaf kalau ada hal-hal yang kurang berkenan dalam penyampaian saya. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Salam Budi Luhur.
Salam Budi Luhur. Baik, terima kasih Pak Wendy. Untuk teman-teman mahasiswa ya, nanti di penghujung acara akan disampaikan sebuah link untuk mendapatkan feedback dari teman-teman semua terkait dengan masukannya di acara ini. Dan teman-teman mahasiswa diharapkan untuk join Zoom ini dengan menggunakan laptop, because nanti akan ada interactive session ya dari pembicara. Baik, kita mulai saja. And I will introduce the guest lecturers from HZ University of Applied Sciences. The first one is Professor Misha Becker. He is also a head of a research group in data science, and he will explain what the benefits are for using the cross-industry standard process or data mining, or something that we can we usually call it as CRISP DM. And also the benefit of CRISP DM activities will be demonstrated using the coding example using Python, and also K9 for visual programming. Yeah, and the second guest lecturer, Mr. Stefan Denijs. He is a lecturer IT consultancy and change management, and he will bring the introduction into data visualization. He will introduce the good, the bad, and the ugly on playing the field of visualizing data. So the first the time is for Misha Becker. Are you ready?
Yes.
Yes.
So thank you for the kind words. Before I start, I would like to say a word of thanks because first of all, we would want to thank the University of Kuliah for the long and the pleasant relationship we already have with each other, with both the universities. We're very pleased to get the opportunity to explore the possibilities for cooperation with the IT program. And a special thanks, I would say, to Pak Wendy and Boer Riet, who also visited us already in Vlissingen at the university. And both of them organized this meeting for us with Rushda. We're very pleased to get the opportunity to do the guest lecture. So thanks for that. I will start with a short introduction into myself. My name is Misha Beckers. I indeed am a professor of data science. I started doing data science, or at that time it was called data mining, at the Radboud University in Nijmegen in the Netherlands. And in 1997, I got my PhD in a subject that was then called chemometrics. And it is actually data mining. We did that already at that time, but it was called chemometrics because we used chemical data coming from chemical experiments and processes. And I used natural computation. It was called genetic algorithms, neural networks, to do structural analysis on actual proteins. And after that, I joined a completely different company, which was then called Kluwer Academic Publishers. It's now known as Springer Verlag, and it's a scientific publishing house. And there I did also data mining. I tried to find structures and patterns in electronic documents to try and find structures that we can use to, make the printing process more efficient. After that, I joined a company which is called Maxton. That's in a beautiful city in the Netherlands. It's called Middelburg. And Maxton is a software house. They have software engineering experts, and there I was manager of research and development. And we try to develop innovative software for the tourism industry. Not too many data mining jobs there, but at least we were doing business intelligence on the tourism data. And at that time, the University of Vlissingen, HZ University of Applied Science, asked me to do some guest lectures and explain to the students how we could use that business intelligence in their in a program, how you could apply that in practice. And I like that. That was nice. The context with the students, trying to get your knowledge and your experience into, these lectures. And at that time, there was a bachelor programming being built, a bachelor programming for IT. And I love that. And so I applied for a job within the HZ University to try and help building that bachelor program. That was in 2005. And since that day, I did a lot for the IT department there, lecturing, being a project leader for research, then becoming the head of department there, and actually where I'm now a professor in data science. So data science is a broad subject, so we need themes to do, say, data science with or on. The themes I've chosen are data-driven asset management, because we have a lot of assets around us in the Netherlands, like bridges and locks, sewer pipes, and all kinds of stuff that needs to be maintained. And to be able to do that more efficiently, we apply data science to that. For instance, to predict whether something might fail or what the remaining lifetime is of assets in those bridges, locks, process industry, valves, and so on. Another theme that I chose is called smart mobility, the mobility of people. So where are people and where can we predict where they are going to move to? But also the mobility of vehicles. So we're now heading to autonomous driving, for instance, or autonomous sailing. And we're trying to apply data science to that. And the last one is smart communication. So that's actually trying to get the message out of, well, maybe videos or images or large texts. So what is actually in there, and we're trying to getting that out with data science. We're doing that via funded research, both directly and subsidized projects. So the Netherlands, that's quite a distance from Indonesia. You can see that here. I've plotted Rotterdam area, Rotterdam airport. And if we zoom in to the Netherlands, which is this country, it's a very small country in Europe, then we have a beautiful province, a region here, which is called Zealand. And you have like these small isles in Zealand, lots of beaches there also. And the capital of this region, Zealand, is called Middelburg. And that's where our university is. I've indicated here with the square. And this is our university building in Middelburg, actually. Maybe it's handy to name some facts or figures about the Netherlands and about the region where we're at. It's a small country. We have about 17.5 million inhabitants. But if we look at Zeeland, the province or the region of Zeeland, there is only 285,000 inhabitants. And in our city, Middelburg, some small 50,000 inhabitants. At our university, we have some 5,000 students, of which 11% are international students, which we're very happy with. And then the University of Applied Science, although it's a rather small university, we have 23 bachelor programs and 1 master program. And at this moment, we are starting to develop further master programs, amongst others, in data science. One of the bachelor programs that's called Information and Communication Technology, so IT actually, with 200 students, and there are 3 tracks in it. Graduation tracks, you might call it: software engineering, data science, and business IT consultancy. So that's where my colleague Stephen and I are from. And we are very proud that we are also building this new building next to the one I showed you. We hope to finalize this in 22. By the end of 22, it's a joint research center where we can do research with all kinds of stakeholders in that beautiful region of Zealand. It's a 4-layer building, and each layer there will be a separate lab, and one of them will be a data science lab. So very excited to be working in that within a couple of years. That was the introduction. What I would like to do today is say something about CRISP-DM, the methodology we use in data science. And then I'm going to take you through an example of doing data science with CRISP-DM and using also Python in that. I'm going to show you some iterations of CRISP-DM on an actual data set, and show you some of the things you can do with Python within these specific phases of CRISP-DM. And if I have the time, I will point you to some further applications of CRISP-DM or Python or other possibilities to do data science. And I will show you some lessons learned from these examples I showed you. So that is what I would like to do today. What I'm not going to do is give you all kinds of definitions of what I think that data science is. That's not that interesting, I would say. It's about how are we going to create value from the data we have. And the first thing I would like to show you is this. In the background, you already see that CRISP-DM methodology. And the nice thing is that you see the arrows in it and you see the circles. So that means then that you can do it iteratively. So many cycles after each other. And what I find is interesting about this picture is it's it's my version of an existing picture from Gardner, is that you can do different things with data. You can use it in different use cases. Most people nowadays think that if you apply data science, that you are only doing predictive things like predictive analytics, predictive maintenance. But it all starts with just describing what you already have, just describing what happened in the past using data. And actually that is called descriptive analytics, and that can be of huge value for a company, an organization, because it's no use doing predictive analytics if you didn't first describe what the situation at this moment is. So we will see that in the examples today, that by just making a simple visualization, for instance, or by just making a simple statistical summary, we are describing a situation as is, and that might provide a lot of value for a company, organization, stakeholders already. So here it is, the famous cross-industry standard process for data mining, in short, CRISP-DM. What you see is a couple of phases, from business understanding via data understanding, data preparation to modeling, and then, of course, evaluation, whether all things went good or wrong, right or wrong. The nice thing about such a methodology is that it's well described. It's a cross-industry standard, so there's lots of documentation available. There's lots of best practices available, and you can find templates to use it, guidelines to use it. And the reason that I find it very attractive is there are well-described deliverables in each of these phases. And I'll show you some of the deliverables in the first phase, business understanding. It's very easy to see what's happening there. You have to understand the business, so you have to involve the stakeholders there. You have to talk to the stakeholders to actually try and find out what the problem is they want you to solve. And then you can try to make a business objective out of that, which are going to solve. And hopefully you can derive data mining goals, because that's what we're trying to do, providing value by analyzing data. And if you come to the conclusion that that won't contribute to the business objectives, you shouldn't do this at all. But most of the times, data will contribute. So if you look at the documentation, you have like kind of, well, it's not quite a cheat sheet, but it's more a guideline how you can use CRISP-DM. And here you have these deliverables, which makes it very transparent to use. I'm not going to explain all these deliverables because you can find them on the internet, you can read about them. But what I would like to emphasize once again is these arrows between these phases. For me, the essence of using CRISP-DM is that it's cyclical, because you go through it in cycles and you produce results very fast. So the first iteration already produces the results, and you're going to improve that in a second iteration. Nice thing about that is that you can show results to your stakeholders very fast and discuss that. So that will add value very quickly. And you can bounce around between these phases, but because once you're in data preparation, you might see that you overlooked some things in data understanding, or once you're modeling, you might see that your model doesn't do very well, and maybe you have to prepare the data differently. So you should be able to just bounce around between these phases also within White Cycle. And that's the nice thing about using CRISP-DM. What I would like to do now is take you through an example, a real life example with data that we actually used. And it's it's an example of tourists visiting Zeeland, the province of Zeeland. We have many tourists visiting Zeeland, and we approach this example from a governmental point of view, because especially in summer season, there are more visitors like tourists in Zeeland than inhabitants. And that causes, that's nice, of course, from an economical point of view, but it also causes some problems. And from a governmental point of view, we could say that the business objective is to find a sustainable balance between the activities of the regional residents, the inhabitants, these visitors, and also the entrepreneurs that are between them. And the environment we have to take care of. And we can try and make that like smart, for instance, by focusing on things like the accessibility of the region, the adaptability, but for also, I would say that safety is one of the most important themes. So we must be sure that emergency teams can reach all the parts of Zeeland fast if needed. So from that business objective, we might derive a data mining goal that says something about how many visitors are there at which moment, and can we predict that from data? Now that's the example we are going to use. I'm going to iterate through that using a specific data set we have. The data set is from its location data that we extracted from cell phones on which there is an app. And the app is installed by tourists who gave us permission to use the track and trace data, which is on their phone. Now, the track and trace data, it's just logging the location of the person at a certain time. So if the person is moving in Zeeland, we have all these location data of where this person was during a day. And we have that data for several years now, and I'm going to focus on the year 2019. So that's the starting point. And now area of interest is what I indicated here with the square. That's the region of Zeeland in the Netherlands. So let's start with our first iteration, and I'm going to set a very easy or simple data mining goal for myself, and that's predict the number of visitors, but we do that only visually. So actually for specific dates or periods, the number of visitors should be displayed. That's a success criterion to measure whether we got the data mining goal right. So fortunately, we got this data in a CSV file, which is very easy. If I would like to import it in Python, maybe you know that already, but Python works with libraries, modules. I import such a module, and pandas is a very important module for us because it has many facilities to create something that's called a data frame, and also lots of functions that you can use to manipulate that data frame. So what I do here, I use a panda read CSV function to read the CSV into a data frame. I call a data frame df. I display it here. And by using the info function applied to my data frame, I get a lot of information about my data frame. For instance, the dimensions of it, how many rows I have, so measurements, how many columns I have, so variables on that measurements, but also the column names in my data frame. What I also see directly is how many of the rows I have missing values for this specific column. What I also see is that there is a data type assigned to my variable. And last but not least, I see the size of this data frame. So by using a very simple function, info, I get a lot of information about my data frame that I created. In the same way, we can do a lot of data understanding by using a handful of these pandas, or actually standard Python functionality. If I would like to know the dimensions of my data frame, I can use the shape function, which gives me two numbers, the number of rows in my data frame and the number of columns in my data frame. If I want to see the column names, I just chain the columns function to my data frame. Max would give me the maximum value of each column in my data frame that has a numerical format, data type, excuse me. But that's for every column. If I would specifically know the maximum value of the column with the column name duration, I just indicate that column by square brackets. Now here's an interesting function. It's called describe. If I apply that to my data frame, it will return a complete statistical summary of my data frame, by which I mean a table which contains for every numerical column the minimum value, the maximum value, the mean, the standard deviation, the number of missing values, the percentage of values in the 25, 50, and 75 quantiles, and so on. So this is very interesting if you would like to understand your data better. Here's a specific concept I would like to emphasize in Python. What you here see, and you also saw it here, is a concept called chaining or pipelining. What you could do in Python is you can apply a function to the data frame and then chain another function to that. And that's a very easy thing to write very compact code. So what is happening here is that actually here a condition is checked. The condition is a value in that data frame available or not available? So is not available would return true or false. But in that case, it does it for the complete data frame. So it would return a data frame where the values are replaced by true or false. If that's not what I'm interested in, I can count the number of truths by just say sum. And then I get a data frame that has only the column name and there the total number of not available values in that column. In the same way, if I chain another sum, it will total the not availables of all the columns. So I can do that in many different ways. And here you have a correlation function which will call return a correlation matrix of all the numerical variables. What I also would like to emphasize is that it's very easy to plot results in Python. You need a module for that, the pyplot model module. Once you have a pyplot model, you can use all these kinds of plot functions, histograms, bar diagrams, box plots, scatter plots, and there's many more. But essentially, if you use this one-line code, you can already create a diagram. And I did that for one of the variables because we were looking for the number of tourists at a certain specific time period. And the number of tourists is, of course, not in our data frame. So I selected one of the columns, the duration of specific users. So user ID has a duration. And I figured out maybe we can use that duration to try and get an indication of how many people are at a certain time at a certain place. But we are in data understanding. So I would like to see how this duration variable is, for instance, distributed. So I could use a box plot just by using this simple line of Python code, it would produce a box plot. Well, it did, but unfortunately, the data is very strangely distributed. You can also see that here. When I try to do a histogram of that duration variable, when I plot the histogram, I hope to see a nice normal distributed variable, but this is very skewed. Most of the values are here, and then you get a long tail, which is also displayed in a box plot. So that's probably a variable that is not useful for our data mining goal. And although the indications are there that it's not useful, I just tried to make a scatter plot in which I used an index, which is the date of on which the duration was measured. And then you get this plot, which immediately says that, no, this is not the right variable to try and get an indication of the number of visitors in time. So we're going to do something else. What's not in the data frame we have is the number of visitors. So you have to figure out a way to count the number of visitors. So the thing we figured out is that we are going to we're going to aggregate on a specific date and count the number of user IDs on that specific date, because then we know the number of tourists on a date. So then to be able to do that, we have to do some data preparation. So we move now to the next phase. I'm going to use another Python function, which I chain to my time start variable. And if I use that, it will display the first 5 values. That's the default for the head function. At this moment, I see that the object type for time start, the data type is object, which says that it's a string. That's not right. It should be a datetime format. So the first data preparation you have to do is get it into a datetime format, and then we can manipulate the date, and more importantly, we can set it as an index in our data frame. So here you see some code when I try to do that. I created, in the meantime, a new variable. You see here a complete timestamp with a date part and a time part, but I'm only interested in the date part. So that's what I extract from that timestamp. Then I convert it to a datetime format. And once I've done that, I set it as an index. And that gives me the possibility to later on aggregate on that specific date. But I would like to do some more data preparation. I already said that I'm interested only in the province of Zeeland, the region of Zeeland. Fortunately, I have a variable which is called address city, which has all these cities displayed, and that gives me an opportunity to select only the rows of which the address city is in this list. And that's a way of subsetting my data frame. It's selecting only the rows that meet a certain condition, and the condition is it has to be in this list. So here you see how I do the subsetting. In my data frame, I make sure that a certain condition is met, which reduces the number of rows in my data frame. And now I'm ready to do what I wanted to do, and that's called aggregating. Because I have my date as an index, I can use a resample function that has as an argument, for instance, D, can also be M for month or a year, Y in that case. But I'm going to D because I want to resample, so aggregate on the day of that datetime format that I have. And then I just chain a function which is called size to that. And then size will give me the number of rows that meet this condition. And then I have the variable I want to have, which is called the frequency or the number of visitors on a certain day. And now if we go back to data understanding, because I already told you we can switch between phases, then I see that my box plot is readable. My histogram is, well, not quite normally distributed because there's a strange dip here, but it's getting there. And what I see in the box plot here is that I immediately see the minimum value, the maximum value. I see the median of my frequency variable. I also gave the argument show means is true. This is the mean. So the mean is, well, actually not exactly the median, which maybe indicates why it's not that normally distributed as I expected. But for now, good enough. And then I can do what I wanted to do. I want to visually display the number of visitors at a certain time. The only thing I have to do is use my plot function. On the x-axis, I plot my index, which is the date in this case. On the y-axis, I plot my frequency, which I just created during data preparation. Using only this line of code is sufficient to plot the diagram I want. But to upgrade it a bit, I add a title, I add a Y label, I rotate the X labels, etc. But here it is. This is the visualization I would have liked to create to meet my data mining criteria. And then you see that, well, this is what you expect in the summer. There's more tourists, obviously. There is something in autumn. There's also a holiday in the Netherlands. So there are some peaks. These dips, these parts are suspect because we don't believe this. There's zero visitors at a specific time in the winter. That's strange. But for now, this is what we are looking for, a visual display of the number of visitors. So we are at the evaluation of iteration 1, actually. So we have a nice visual impression of the number of visitors. We can see that for specific dates or periods of times. We see expected peaks and also some non-expected parts at the beginning of the end. So now we're ready to define the next steps. And actually, we're talking about prediction. So we would like to do an actual prediction, maybe by using the previous values of the frequency. So just using the frequency itself to do a prediction, so univariate. And then I have to change my data mining goal a bit. So now I'm going to predict the number of visitors using time series analysis, but that's actually what you do if you use the frequency itself to do the prediction. But when is it good enough? Then we have to use a metric, a success criterion. So I introduce the mean absolute error for the prediction. And when is it good enough? Well, let's introduce a benchmark value for that. I'm going to show you later on what I mean by that, a benchmark value. And then a prediction is only usable if you can predict ahead. So make a forecast. And let's say we will try to predict 10 days ahead. I'm not going into much detail about the time series analysis that I use, but it's called ARIMA. It has an autoregressive part. That's a linear combination of the previous value of the time you are going to predict, and it has a moving average part, and that's this part. And in that case, you move a window on previous values you calculate the average, and then what is here displayed is the residual between the predicted value by that moving average and the real value. So there's two components in ARIMA, auto-regressive part and moving average part. Now you see here 3 parameters that I can give the ARIMA function. The first part is the time lag for the regressive part. So how many time periods should we go back? The same for the moving average part. How many time periods should we go back? And this one I shall explain. Usually in time series, you can see some trends or seasonal effects. And that makes it not stationary. And this ARIMA function expects a stationary input. So once you concluded that there is a trend, for instance, then you can remove the trend by using an order of a differentiation of 1. If it's cubical, you use order of 3. Now, Python has libraries for handling time series. It's called stats models. And this beautiful function here, seasonal decompose, decomposes our data frame in which the frequency is there into 4 diagrams. First one is just our original. It's the frequency plotted against the time. The second one is the trend that is deduced from that. And you see the trend here. It's going up and it's flattening a bit. The third one is the seasonal effect. So you see all these periods here. And if you decompose that, then there is a repeating pattern every, well, what should it be? 7. It's not exactly a month, it's a part of a month. And then you see the residuals. But the most important part is we see a trend and we see a seasonal effect, and that influences our D factor. Now we can remove that trend. That's an interesting exercise to do by using a function called diff, and that calculates the difference between an actual value and the previous value. And if you do that once, you're able to remove a linear trend. And if you do that twice, which what I did here, then also you are able to remove a cubical trend. Now, I did that on our data frame. The result is this. There's no linear trend to see. There's no cubical trend to see. That gives me the impression that I have to use DS1 or DS2 order in my ARIMA. I'm going to introduce a second data preparation step here. We are now trying to fit a model on our training data. If we do that on a complete set of training data, then obviously we'll create a model that fits exactly on that training data. And probably that's not a robust model. It's not generalizing then because, well, it has only seen the training data. What will happen if we use input data that it has never seen? Probably it's going to overfit on the training data. To avoid that, we can apply a test design. And in that, we create 2 sets of data, one to train the model and one to test the model. So the test set is used to give to the model, ensuring that it has never seen this data. And then we are going to evaluate how well it produce or performs on that. I see a hand. I'm not sure. Kuliah, should I interact now, or should we do that in the end? Can you give me some direction on that?
It was a question regarding contact details, Misha. So it was not.
Okay. We'll do that later.
Yeah, I will check the chat, and once the question arises, I will let you know.
Thank you. Okay. We've created train and a test set now. I will use the train set to train the model and then the test set to, well, actually to test the performance. I mentioned the benchmark because, well, once we created the model, we have to get an indication how well it performs. So suppose that we didn't have a clue about what a model could do, and we just make a wild guess for prediction, then the most easy thing we can do is just calculate the average of the known values of frequency and use that as a prediction value. So that's what I do here. I say, well, I have my frequencies of the test set, and I just calculate the mean for that. And then I create a column, a vector array, whatever you call that, of those values. So the benchmark predictions column has all the same values. It's the mean of the frequency. And between my test values, the actual frequencies, and that benchmark, so the mean of the frequencies, between those values, I can calculate a mean absolute error. And in this case would mean the mean absolute error for the prediction. So here you see the benchmark value, the mean of my frequencies, and here are the actual values for my test set. And between those values, I can calculate the mean absolute error, which in this case is 340. That's maybe good to memorize. 340 for the benchmark. Now, here we go. The ARIMA time series analysis. Very easy to use because it is in the stats model package from Python. What I input is my train set, and I have to give it some parameters. Here is the P time lag. So for my autoregressive part, I saw that it's not stationary, so I have to use a differentiating order of 1 or 2. I chose 2. And here I have a time lag for my moving average part. This is the initiation of the model for training. And by using the fit function, I actually train my model. And now for the forecast function, I'm going to use the test set, and that produces a mean absolute error of 170. So that's beautiful because that's far less than the benchmark, to say the least. Maybe for those interested, these specific values, I've created those by using actually a loop for a large range of p-values. D is 0, 1, or 2 value, and a large range for the q values. And then looking at the combination of these 3 that produces the lowest mean absolute error, and that was this. And then the result for the test set is, you see here the real values in my test set, and you see the predicted values. It's close. It's close. It's not exactly matched, but it's close, and obviously far more better than doing such a simple benchmark. Now, I can improve that model because you not only have ARIMA, you also have SARIMA, which has another set of parameters that you can use, which will model actually the seasonality. The X that's an additional model. Then you can use some additional variables next to the autoregressive part and the moving average part. I'm not going to use that because it will improve the model slightly, but I will focus on the problem with these time series analysis, because the previous slide here, I showed you the results for the complete test set, but not further than that. But remember that we set a criterion in our data mining goal that said we should be able to predict 10 days ahead. Now, to simulate that, I split my complete set again. And here I have the training set that went up to this date. And I have an actual set that started from this date. So now I have a different test set. It has never seen it, but it's also not included in this known area where we have data. And then you see, if we do the forecast, it has some difficulties with forecasting that. It starts too low, and that's not surprisingly because this enormous dip here. But suppose we want to move further ahead, then we have no data in retrospective to calculate moving averages or do autoregression. So it works to a certain extent. Certainly the mean absolute error of prediction is less than the benchmark. Yes, that's the data's mining goal we easily could beat. But a reliable forecast 10 days ahead, that might be a problem. And that's in the nature of the modeling procedure in which you include previous values for the frequency. So to a certain extent, nice model, but there is limitations to that. And it might be also in that these non-expected parts which move in a strange way. So that was iteration 2. At that moment, we thought, well, nice one, but let's try and use a model in which we not do the prediction based on the frequency itself, so actually the rows in the data set, but let's try and do the prediction based on the variables, so the columns in the data set. Can we find combinations of those variables that are that going to predict our frequency? So that's a multivariate approach in contrast to the univariate approach where we do the prediction on the frequency. Now we have a multivariate approach, and we have to create new variables that are likely to influence the number of visitors. So I hope that you are now already thinking about what kind of variables that might be. And some of them are quite easy, we will see. But we have to set new data mining goals, obviously. So now we're going to an area which is called machine learning, and we're going to use a multivariate approach. Again, mean absolute error of prediction has to be less than the previous model, not the benchmark. We already beat that, but the previous model. And we have to do a reliable forecast for 10 days ahead. Okay. First thing we came up with, the weather, that has to do something with the number of tourists, obviously. So we are going to include weather data. What you see here is a data frame that we could easily construct. We have all kinds of APIs where we can download weather information. We have a weather station at a certain location, a timestamp, the hour of the day, and then all these variables, some 22 variables about wind speed, temperature, numbers of sun, numbers of rainfall, etc. We selected some of these variables and we created new variables from these weather data. So again, we're in preparation. For instance, we were interested in how many, let's rephrase that. Did it rain in the morning or did it rain in the afternoon? That's a variable that's not in that data set. Obviously, there's information about rain, but not this. Did it rain in the morning or in the afternoon? So there's a data preparation trick for it. First, we have to define what is morning and what is afternoon. So here you see some subsetting that we did. Is it in this list or in this list? And once we know that, then we can do a specific aggregation trick in which we are looking for the millimeters of rain and we sum that over this period or that period. And once we have this, we can merge it with the original data frame and take up that additional variable. An additional data preparation that is very popular if you have a timestamp is extract the year or the month or the day of the week or the day of the month from that timestamp. That's very easy if you have a timestamp that is in the date time format. And as we already saw, we have a timestamp that is in date time format. So we can extract these. And then we have 4 additional variables. And on top of that, we can create an additional variable, which is called weekend. Is it weekend or not? And it's again a subsetting trick. And last but not least, we included a list of holidays in the Netherlands with which we could create an additional variable. Is it a holiday or not? So those are all, well, kind of binary variables. So by using these data preparation tricks, we created a data frame that's displayed here. For a certain day, we have all these additional variables, the month of that timestamp or that measurement, the day of the month, day of the week, is it a weekend or not, is it a holiday or not. Here is the frequency, that's our target, as we know. What was the wind speed, the temperature, the hours of sunshine, and did it rain in the morning, or how many millimeters of rain did fall in the morning or in the afternoon. So that's an interesting data frame. So what we are now going to do, we said we are going to do a multivariate analysis. So from all these variables, features, we call them, we're going to try and predict this frequency. One thing we also have to do is a trick that's called one-hot encoding, or creating dummy variables. And we need that because this is a tricky one. Also this, obviously. It looks like a variable that's in numerical data format, but actually it's a sort of a category, right? It suggests an order, like 6 is more than 3, but that's not what you want, because then the model is going to try and learn that this is higher than this. So what you can do is create a dummy variable that says, is it a weekday 2? Is it a weekday 3? And then you get a binary variable for that. So for weekdays, you get 6 dummy variables, and then you get rid of that order. It's binary variable.
Misha, there is a question in the chat regarding the tests. Can you open the chat maybe?
Yep. Yeah. Okay, thank you for the question. It's about performance tests. Yeah, I would guess that performance about the machines you're running it on. So the time it takes to do actual training and testing. Is that correct? I'm not sure it's correct, but I assume it's about that. The examples I used today, these are such simple data sets that it's no problem to do that on your own laptop, for instance. It's mainly numerical data, so not images or text or whatever. So that's quite easy to handle for a CPU. We don't need GPUs for that, for handling images, for instance. I'm going to check.
So, sir, this is about more our specification for handle that data. I mean, you were doing a research for this kind of huge data. What is the specification that can handle that data? Is that correct?
The specification for handling that data. You mean the quality of the data then, or?
Pardon, sir?
If you talk about the specification of the data, do you mean the quality of that data? Is that included in your specification?
Yeah. That's also right. But sometimes that to handle a kind of huge data, we have to also understand the specification of our hardware, how many data that can handle. Is that what do you mean about this performance test in this model, or how?
No. Performance in this model is just how well the prediction is done. So performance in what I'm telling you today is about the model itself. If you talk about performance on the hardware or the infrastructure or something, that's not a topic that I'm discussing today.
Okay, now I understand. Yeah. Okay. So it's more about the functionality of the model, how they can handle to process the data that we have.
Definitely, exactly.
Okay.
Yeah,
okay, good.
right.
Okay, thank you for the answer.
Thank you.
Yeah.
Okay. Let's see. So this is the data frame we created. We have features, the variables here, and with those features, we're going to try and predict the frequency. So first, we will try to make a simple linear regression. A linear regression means that we are going to build a model that is just an addition of all those variables with their coefficients to try and come up with the frequency. Now, you saw already that we had a test design with the time series analysis. Now we have something different as an input. We don't have one variable, but we have many variables. So we have a data frame as input. So we need another functionality to create a train and a test set. And that's the nice thing about Python. You can just create a line of code that looks like this, in which you, in one step, create 4 new data sets. Because I have my input for the train set and the output for the train set. I have my input for the test set and my output for the test set. And then again, I have to import my linear regression function, in this case, from a module which is called sklearn, and that's hugely important for data mining. Sklearn has a lot of models that you can use. Here again, I initialize my model. I fit my features for my train set to my target for my train set. Here I have trained my model, and now I'm going to use the model to predict the target values from my test set. And then I'm able to create a mean absolute error from that. And here it is, the mean absolute error. And oh, I see that it's a bit higher than from my time series model. So what does it look like? Oh, sorry. If I create a linear regression model with all these variables, and you see here these dummy variables, I can calculate the importance of the variables, which makes my linear regression model a kind of explainable. I can explain which of the variables contributes which effect to my prediction. And it looks like this. Now, on the y-axis, I don't have my date anymore. And that's an important difference with the previous analysis. That doesn't, it's not important to have a date here, because I now are going to predict my frequency from a set of variables, such as the day of the week, or the number of the millimeters of rain in the morning. So once I have that, I'm not interested anymore in the time order here. It's just how well does it fit on my frequency. And you see the fit, that it follows a certain pattern, but there are certain misses also here, for instance. This is a way to express that, but usually what we do, we create a plot like this in which we display the predicted values against the actual values, and ideally it should be on that red line, of course, but it's a bit scattered around that. Now, we saw a linear regression. We have other models to do regression. For instance, a gradient boosting model. I'm not going to explain that. You can read the code if you would like to do that, but you see immediately that you can tune that. There's much more arguments here that you can use. The rest is obviously the same, and indeed the model improved. It's going towards that 170 from the time series analysis. And now you see that it follows the pattern quite accurately. And you see that the scattering around that red line is a bit less now. So we're getting there. And if we summarize that in our evaluation, we see that, the mean absolute error for prediction is not less than the previous model. It's approaching it, but it's not less. But now we are able to predict 10 days ahead because we're not relying anymore on the previous value of that frequency variable. We're now using other variables to predict our frequency. And obviously there are a lot of steps that we can do in the next iterations. One of them is a special one. It's called scaling the variables, and I'm sure that is one that is going to improve my performance much more, because maybe you saw it, but the range of values between the variables is large. Some of the variables vary between 0 and 1, and some of them between 0 and a few hundreds. So scaling that to, for instance, a min-max value or z-factor value makes them more comparable, and that would improve it. There's many more things that we can do, but there's no time to explain that. Obviously, I just wanted to show you how we deal with iterations and the benefits of that in CRISP-DM. So actually, this is what I used in the evaluation parts of these 3 models. So how we could compare them and where the pros and cons of these 3 iterations were. You saw that I used supervised learning, machine learning in the last iteration, and a specific kind of supervised learning called regression, because I had a numerical variable. The frequency is a numerical variable. Had I had a non-numerical variable, then I could have done classification, but the principle is the same. You have features with which you can predict a target. I showed you a data frame with mainly numerical variables, and the data frame is nicely structured. It has columns and it has rows. It's actually a table. Many of the data sets we have are not structured. You have text, you have sensor data, you have images and videos. But obviously in the data preparation, you can create data frames of it. An image is nothing more than a matrix with pixel values. So obviously you can transform that to a data frame. And then you have structured data, and then you can do the same that I did earlier. These are some of the projects in which we applied that. I'm not going to discuss that now because I see I ran out of time. So I'm going through another couple of slides a bit more fast. I showed you some tips and tricks in Python. Python is hugely popular in data science, and there's much more tools coming available, but what I also showed you that you have to be careful with these models, because all these models will produce output, but you have to be able to do the interpretation of the output. How well does it fit my needs? and is it statistically acceptable? So that's very important. I included some pointers to other environments that you can use to do exactly the same that I did today. An alternative for Python is the programming language R, and then you see three other links, Orange, Nime, and RapidMiner. That's actually not a programming language, but it's a visual way of doing data science. So there you have widgets that you can chain on a canvas to do exactly the same that I did today, and far more complicated things. So that would be interesting to have a look at if you are interested. Actually, that was what I wanted to discuss and share with you, and I'm honored that I have the opportunity to have done that with you. I saw some questions. I'm not sure I'm going to ask that to Bawusha if you are going to do that now, but if you have questions after that, I'm ready to answer them via mail or whatever. So I give the microphone to Bawusha.
Okay, thank you very much for the explanation. Yes, some of the participants has already asked you in the Zoom chat, and they ask for your email also.
Yeah.
Please, if you don't mind, you will provide it in the Zoom chat. Thank you then. I think it's better to answer at least another 2 questions before Mr. Stefan do the presentation. The first one is come from the Patlisan. Patlisan asked how to identify data to be processed. For example, I only have product code and quantity per month data. Can we transform data like this into data mining? Probably he asked you, he has only 2 attributes of data, consists of product code and quantity per month. And what kind of perhaps what kind of task in data mining that can be done into this kind of data?
Yeah. What we usually do in that case is that can we find additional information on product code? For instance, can we group them together? Because if you can group them, then you have another variable, the group to which a certain product code belongs, for instance. And it depends a bit on the metadata you have on these on the product itself, because if you only have a product code, then probably it would have a description and a name and a color or a size. I'm not sure what kind of project it is. But if you have that, I would certainly include that directly in our data frame. The same holds for the quantity. If you have a quantity per month, then there's not too much that you can do with it, except for trying to find some differential or difference variable. So you can, for instance, calculate the difference of this month compared to the previous month or over a larger period of time, and then you could see a delta. So how much is it growing in a certain period of time? So that's also things you can do with a numerical variable being actually the only variable you have.
And if I'm not mistaken, this is why we have to come to this virtual loom to learn from you about the CRIPS DM, right? Because this is some mistaken that usually done by the student, I think. They only focus on the data, but forget about the first step, business understanding. The first step is a must, yeah? I think Prof. Misa has already explained to us that the interpretation of the data, it depends on our understanding of the goals of the business, yes? And this should be followed first by first, step by step, starting from the business understanding.
Exactly. Yeah, you're completely right. Yeah, the first step, business understanding, is important to get a feeling of the business you're doing the research for, And then once you have the data, then it's called business data understanding. So you have to find as much information as you can about the data. And if you have some metadata, documents about it, or whatever, or maybe you are able to try and interview someone that has knowledge about the data, then you can expand it and you can create additional variables or do something with that data. Yeah, it's those phases are very important. The two starting phases. Yeah.
Okay, we go to the second question. How do we avoid and deal with underfit and or overfit models? Maybe you can give some example.
Yeah.
From Pak Ahmad Solihin here.
Yeah, very good question. Yeah. One of the major things that you have to do to try and avoid overfitting is, well, at least create a test and a train set. That's the most easy thing you can do. But the pitfall or drawback by doing that is that you do it once. So you have one test set and one training set. To do it properly, you should create more than one permutation of that. So if you go further, then you can do that in a loop, for instance, and then you can plot the results. You can plot the mean absolute error of training and testing in one set, and there is a point where these two are going to come close together or go what is the word, converge, diverge, I'm not sure, but that's a possibility to do. And an even better possibility is to use something that is called cross-validation or k-fold validation, in which you have an automatic procedure to, well, randomly pick the measurements so that they go in your test set. So there are more advanced techniques than what I showed you today to try and avoid overfitting.
Okay, thank you for the answers. I think I'm sure that we still so many questions in our mind, but we have limited time. So this is the time for Mr. Stefan to do the presentation. Please. I think you have another 45 until 50 minutes. Is this enough?
I will try to fit it in.
Okay.
I will do my utmost best. So I hope you can see my screen now.
Yes,
okay,
already.
Thank you. So yeah, welcome all to this introduction to data visualization. As we've seen in the lecture from Misha, it's really easy with Python to create visuals. But the part I want to discuss with you is that sometimes you also have to think, what do you want to show and how do you want to show it? Because it's that easy to do a plot or a bubble chart or anything like that, you will automatically just create one with Python. But there's more thought you can bring into data visualization itself. And now, let's first introduce myself a bit. This is me. Surprise, surprise. This is me. I'm Stefan de Nijs. I'm 36 years old, and I live in Halster, which is near Zeeland. The picture that Misha showed. I started as a student at the HZ myself as well, all the way in the beginning of this millennium. Afterwards, I graduated. I started working at a very small firm as a tester, as a software tester. Then afterwards, I went to Accenture, and there I became a business intelligence consultant and worked with a lot of big companies like KPN, Shell. I don't know whether you know Ascent and Oleander that much, but they are energy firms. Especially during the rollout of smart metering, I was there to create a dashboarding to show how quickly and how well the rollout went. Yeah, so I have quite some experience in the data field itself. Also regarding data migration, what I did a lot was when they created a new system, the data had to come from the old system and went into the new system. And you have to diverge your data in some manner that it will fit the new system as well. So that's basically my background. And then I do have spare time as well. What do I do in my spare time? I like to read books regarding IT, but also fictional. Of course, traveling, which is a bit difficult at the moment. But as Wendy said in the beginning, once we are back allowed to go to Indonesia again, I will most probably go back there again. And one side hobby of me is crossfitting. So I lost quite some body weight in the last couple of years, and I'm still progressing in that as well. And I also enjoy just watching Netflix, just sitting on the couch and relaxing a bit. So that's me in a nutshell. Sometimes there is a delay in my... but what do I want to talk about today? There is a new term called informavore. I don't know if you are familiar with that new word, but basically it characterizes an organism that consumes information. We used to consume food or intellectual part as well, but nowadays all we want to see is information. You see it in the business, you see it also on social media. People are gathering information, and they do have a lot of access to all information which is out there. So that's why they called you informavore. You want to consume a whole lot of information. And that's also what we see in modern society, that people actually want to consume as much information as possible. Now, how is that possible? If we look over the last 2 years alone, we see that almost 90% of the data in the world was generated only in the last 2 years. So you can imagine that the speed in which we create data and get data toward our eyes is growing rapidly. And every year they have a visual which is shown on the sheet with how quickly is everything growing. So especially if you see that, for instance, Zoom, which we make use of, that every minute in 2020, 208,000 participants were in meetings every minute. So you can imagine that the amount of data is growing rapidly, and also the internet is very important to get all those data to us as well. And if we check Netflix, for instance, what I like to do in my spare time, you see that each minute almost 400,000 hours of video are being streamed worldwide. So it's huge. Now there is the converge between the generation of data, generating the data, and showing the data, because I hope you can imagine that when information grows and data becomes bigger and bigger, it's really important to visualize the data to consume it even more easily. I have one video showing that, and I hope that the admin can start the video. It's a video of Hans Rosling. He was one of the first creating almost a 3D version of visualization. I see it's being started. Thanks.
Visualization is right at the heart of my own work too. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space, with a bit of technical assistance from the crew.
So, here we go. First, an axis for health, life expectancy, from 25 years to 75 years. And down here, an axis for wealth, income per person, $400, $4,000, and $40,000. So down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Europe brown, Asia red, Middle East green, Africa south of Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population. And in 1810, it was pretty crowded down there, wasn't it? All countries were sick and poor. Life expectancy were below 40 in all countries. And only UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe! And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forge on towards greater wealth and health. Japan and some others try to follow, but most countries stay down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short lives. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier and healthier. And in the 1970s, then countries in Asia and Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see the world today in the most up-to-date statistics. Most people today live in the middle, but there are huge differences at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages, but I can split them. Take China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor inland province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa.
And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future. With aid, trade, green technology and peace, it's fully possible that everyone can make it to the healthy, wealthy corner.
Well, what you have seen in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers. Pretty neat, huh?
So that's the story of Hans Rosling, who is looking into a lot of data points. And as shown, it's within 4 minutes, it will show you what the outcome is of 200 countries over 200 years. Yeah, I have said it's millions of data points. He talks about 120,000. But of course, each country has it per day limited. So in essence, it shows millions of data points transforming into an easy overview. And you should imagine how much time it would cost you if you want to read all about it. If you want to read per country, per year, how the index is going, the population is going, it will consume a lot of time. So the way he visualizes it takes less time to gain knowledge regarding the information. And the nice part he did as well is, beside the 2 axes he also used the size of the bubble. So the size of the bubble showed you the population size of a country in a specific time period, which gives you an additional axis without having an additional axis shown into the visualization. So you get a lot of information in a very short time, and that's basically what we aim for with data visualization: make data more accessible, more easy to read, instead of reading reports of tens of pages. If we go back to the part what Misha discussed with us, it's the CRISP-DM cycle. Basically, there are 3 moments in the CRISP-DM cycle in which we create visualizations. But sometimes they can be different. It can be for analysis purposes, but it can also be for communication purposes. So I've numbered 3 points in time. I would like to ask you to put in the chat where you expect the communication part will come in. Can I also see the chat? I guess I should be able to see it. So it's if you would be so kind, where communication pops in, if it's 1, 2, or 3. Data understanding, okay. Okay, everybody expects data understanding. I can imagine, but basically in the end for communication, it's the end of the CRISP-DM cycle, which means it's in the deployment part. When you're doing data understanding, you're using the data, you're visualizing it, you will see the graphs, but that's basically for analysis purposes. You're analyzing the data still. You're trying to understand the data, analyzing the data. Later on, when you're modeling, you're still in the phase where you can go back to data understanding, where it's still analysis. And in the end, the part where you basically go out of the cycle is the deployment part. You're actually completely done with your analysis. You covered the company, you covered the data, you put your model, you evaluated it with your client or customer. And then in the end, you go to deployment, which is the part where you will communicate the outcome of all your research. And that's the part where we're actually focusing on with data visualization as the course as we give it at HZ, as we mainly focus on how to communicate data from your research. It's time to go to the next one. Yeah, so the learning goals, what can you expect in the upcoming, I think 35 minutes I still have. So you will basically know what a data visualization is. You will know the history and the evaluation of data visualization. So we go all the way back in history to show where do the data visualizations come from. And in the end, you will know some visualization errors. Like I said, the good, the bad, and the ugly. There are some bad and ugly data visualizations out there. And we will cover some of them. In case you found this part of IT interesting, these are 3 great books to read. You can find them as ebooks online as well. We use this as a basis for our course, which is Data Visualization by Andy Kirk, Visual Thinking for Design by Colin Ware, which is a bit more theoretical. So data visualization is more story related. And in the end, you have and now you see it from Stephen Few, which is also a big name in visualization world. So in case you want to read more about it, I can advise you these 3 books. Yeah, so regarding data visualization, I think I will skip this one for the sake of time. Basically, what do you do with a data visualization when you start creating it? Basically, it's the representation and presentation of data to facilitate understanding, which is a very big sentence, but it's narrowed down here as well. If you see the representation, it shows you all kind of charts which you can use to visualize. So you have a circle diagram, you have a bar chart, a waffle map, how do you call it? An actual map with information. So you always have to think what kind of chart would be the best suited to show your data. And then presentation, which is really regarding the colors you use, the scale you use, because it can be that you start your axis not with 0, but with 40 or 50, for instance, to give a better overview of the difference of your charts as well. And regarding color, it's also sometimes you have to take into account that it can be colorblind, or you have to imagine that if you use the color red, people automatically think it's a bad thing, and when you use green, people automatically think it's a good thing. So those are all things you have to take into account when deciding to create your visualization. now of data, which is your extensive list of data which is available, to facilitate understanding, which means you have a huge chunk of data and you make it really easily readable for your audience. Because your audience, when looking at a data visualization, most of the time go through these three phases. You do it subconscious, so you don't automatically know that you're doing it, but most of the time this is the way you look at a data visualization. The first thing you do is you think about what does it show you? What is big? What is small? How do these things compare what I see? Are there any relationships in what I see? So that's the first thing you automatically ask yourself. Then we go to interpreting. But what does it mean what I'm seeing? Is it good? What is bad? Is it meaningful? Is it unusual? Is it expected? So these are all questions you get just by looking at a picture. And then in the end, you go to the phase which is called comprehending, which means what does it mean to me? So I see this picture now, but what do I have to do with it? Is it something do I have to take actions? What did I actually learn? What is the main message people sending here? So like I said, in my career, I created a lot of BI dashboarding, and especially when the management looks at it and they see something red, they will automatically start asking questions on the red part. What can we do? How can we make it better? What to do next time? If you make the color orange, for instance, people tend to get less active. So those are all things you can take into account. Now this is an overview. Does any of you know what a winglet or a spangle is? You can put it in the chat if you want. Because basically you get this picture, you see it, you usually look at the title, you see winglet and spangle. I see some dates on the bottom. Leo, no, okay. And then I can help you because basically these things doesn't exist. So there is no winglet and spangle, but you have to imagine if I give additional context to it, you will better understand this graph. Because in the end, it's the games that Lionel Messi played for Barcelona and how many goals he made. So it's the exact same chart as I showed before. But before, Leo is pretty understanding that you had no clue what a winglet and a spangle is because it's just a made-up name. But now I've given you context. Now you understand this chart a bit better, at least if you know Messi and Barcelona, because else it's still doubtful whether you understand this this chart. It shows you the games he played and the amount of goals he made, which is at some points pretty impressive. So you see, once you generate a data visualization, it's really important that you understand the audience you're creating the data visualization for. So if it's management and they already know with all the terms they have within the company, then you can just make use of those. If they don't understand any of those words, you have to elaborate a bit more or put a legenda next to it explaining what everything means. Then this is something which is sometimes a bit used amongst each other. There is a difference between the data visualization and an infographic. So here you see an infographic of an infographic. But basically in an infographic, you always want to tell a story. There is a story somebody wants to tell, which is subjective. When creating data visualization, you have to be objective as much as you can be regarding the data that you have. Which doesn't mean that you can use data visualizations in your infographic, but in essence, there's a big difference between the two. Now, what does Google think? The left side is the part it will show you if you type in data visualizations. So you see a lot of pie charts, a lot of diagrams, line diagrams. And on the right side, you see the infographics, just a couple of them, just telling you a story, which is basically storytelling with data. If that is your interest, that's more towards infographic. So in essence, the difference between the two. Data visualization, it shows you the raw values, it delivers information, and it has to be objective. So you have to be, your opinion should not flow through your graphs that you're showing. If you have an infographic, basically you visualize a story, you provide a stance, and you offer subjectivity. So basically you want to give your opinion to the crowd. Then it's more a time to use the infographic part. Now we do a little bit back. We go a little bit back in history. Where did it all come from? Whom of you knows or thinks to know what this is? Of course, it's a rock. What do you think it will tell us? So in the end, you see some lines in it. And this is one of the earliest visualizations they found. Maybe it's difficult to see. About hunting animals. Yeah, you're really right, Leo. Basically, it's a map. Primitive notes, yes, about hunting animals. Yeah, primitive notes. So they deducted everything scratched on that stone, and they've shown it here as a picture. And basically what you can see here are the animals, but also some creeks. So basically this is one of the first Google Maps they actually created in the Stone Age somewhere. Here it's a little bit more elaborate. It shows you the deer, the passes, the caves, the mountains. So basically, back then they already thought, I have a lot of information, I want to show it to others. Of course, back then there were no papers and pens, so they had to do it in stone. And this is what you get. This is what it shows you, which is really nice if you found this. And here's one more. Then they colored it. Then you can actually see what everything means. So it really helps for hunting animals. So a great answer, Leo. Then we go a little bit further, 300 before Christ. So this looks already a bit more like a tool we're currently using from Microsoft. This looks a bit like an Excel file, which again is a very old tablet. It's written in stone, and it holds salary information. And it was found in Iraq somewhere in a temple, and it was all the money the employees got. And then we make a big jump, the first map of the world. So it looks a little bit different than we have it nowadays. But this was already the first attempt of creating a map of the world. Then astronomy kicked in. So we wanted to see a lot of the planets, how they moved over time. And this is also the first time they included additional axes. So we already see the X and the Y axis, and they put their information in it. So you already start seeing the data visualization as we know it now. Then we go to the 16th century. So this is the first visualization of static data. So there are a lot of data types, as you might know. Static data is one of those. So what they did is they guessed the difference between Toledo and Roma, and then everybody pinched in where they thought Roma would be. I think this is the distance, and then they predicted it. So this is the first time they already start putting static data into a visualization. Then we jump 2 centuries ahead. They already improved on the map visualization with geological data, economical data, and medical data. So you see also the how do we say, the data gathering always is getting better and better and bigger as it was compared to the beginning. What we see here is when they lived and how long they lived. So if there were a lot of philosophers, I guess, in here as well, and Greek heroes, and it shows you the year they were born until the time they passed away, and this is already visualizing that kind of data as well. And what we see here is that for some people they didn't know, so they put in dots. So it might be this year, it might be this year. So those are not really trustworthy, so to say. Then they are starting to comparing two things to each other. So usually what we do with data is you say, I want to see X over time. Or like the question was the product quantity per month over a certain period of time. That's what they do here as well. They will show you what is the price of the wheat they have and what are the weekly wages people are getting. So you see the weekly wages are going up, but also the price of wheat is going up. So yeah, they start trying to comparing data points they have over a specific period of time. Now, the 1850 to the 1900s is the part they call the golden age of data graphics. And here we already see graphs like we're used to it at this very moment. The line graphs are graphs you will see by far the most together with the bar charts. But back then, they also had the first international conference regarding the discipline of visualization. So that is the first part in time they will actually come together and decide some rules on how to visualize it. And like I said, the first charts, as we know them, are already popping up. This one was a very important map. Back then, there was a huge cholera outbreak in London, and nobody understood where it came from until John Snow, which was his actual name, started to create a map and put in where the pump was in the city and where the cases of cholera were. And then they noticed that regarding this specific pump in Broad Street, there were a lot of cases. So then they understood that this pump specifically was poisonous. And then they put it out of commission. And then they see a drop of cholera back then, very big back then. So you see that just by all the information is already there, but just by visualizing it, you can make more sense out of it. In Europe, this is one of the most famous visualizations, as it contains a lot of data. It was the march of Napoleon going through Russia in the early 1800s, with this line showing you the amount of people that were there in his army, divided over different cities as well, and of course getting less and less. It shows you the cities where they went to, it shows you the rivers they had to cross, and in the bottom it even shows you the temperature it was at that specific moment, because Napoleon forgot that it was really cold in Russia, so nobody of his army was well dressed for the climate over there. So you see that they put a lot of information in one visualization, which this is one by far the most known picture over here. Oh, I skipped one. So after 1900, yeah, they call it the dark age of data visualization. Hans Rosling also mentioned it was the First and Second World War, so they put less effort in data visualization. But they saw that after the 1950s, it grew again, and it grew again quite big and quite enormously, especially also because of some experts on data and especially visualization, which is Chucky and Bertin. And of course, they start implementing technical improvements. So technology made it also more easy to create these graphs, which will also help, of course. So this is this already looks a bit more like what Misha's shown us. So you have the line of everything, of every data point over a couple of years. And then in the end, the big line here, it's the median. So it's the average of all the other lines combined, showing you what the average is regarding this topic is the export from UK. You see that it rose quite big in the beginning, with the industrial revolution, and then it flattened a bit. Mouse clicked away, but it's fine. So in conclusion, history related, we saw the early maps, we saw the stones, then they already start the measurement and theory a little bit. New graphic firms were incorporated. We also saw there was a conference regarding this. Then you see a real peak in data visualization. Then afterwards we see a little bit of the drop. This part in the end for Europe should also go up as well, but Northern America really went up with visualizing their data, as the technology made it way more easy to create visualizations. But back to the here and now. So at the moment, like I said in the beginning, we have a lot of data. There are a lot of tools and a lot of technical possibilities. But then we should only create masterpieces, I guess, right? But this is also what we create nowadays. Yeah. What is the most appealing towards this the picture? What does stand out the most? If you look at this, does it say anything? Maybe you can put it in the chat a bit. It's confusing, yeah. Other, yeah. So it's too jammed. Yeah, you put all already in there. So it's way too many data is trying to be shown here. You even though you have a lot of data like this, please filter it somewhere to make it readable, because this doesn't say that much. I cannot make anything out of it. And like Sija, I hope I pronounced your name correctly, and Novanda, the other. So you have these many categories and still you manage to get the other, and the other is by far the biggest. So even besides all this, there's even more. And of course the coloring, because sometimes you cannot really diverge this color from this color from this color. So where does it show up in the map? So even though we have the technologies nowadays, still there are some errors. This one is also a nice one, example I always use. When you make a visualization, 3D is not always the best solution, as you might lose track of data which is actually there. Because in the end, the 2004 or 2006 part, you can barely read because of the other pillars being in there. And yeah, somebody thought it would be great to add a picture as a background, but in the end, it makes it less readable because of that. So if we can draw a lesson from this, it's to limit the 3D. And if you include pictures, make sure it's relaxing to the eye and not too crowded. Now, what is the most, what can you say about this picture? We saw that America was way ahead with visualizations. But if we look at this one, I see something being wrong here. Yeah, exactly. Yeah, everybody had it correct. Thank you for answering. The value in your hand is not correct. So this is a chart which does not suit the data you have. Basically, this should have been a bar chart. Or CIFA, it looks like the percentage is wrong. That could also be the case. It could also be the case that the percentage is wrong. But usually they say, they do a questionnaire and they think, who do you think will be the presidential candidate? And then people will answer, and then you can have more than 100%. But this is not the way to visualize it. Basically, this should have been a bar chart with Beck Palin being the #1 contestant, then Beck, and then Huckabee, and then Romney. So basically, this is a wrong chart. It's normally US elections. Yes, it is. I usually have a lot of my material with the ugly comes from the American elections. Yeah, you may back one or more. Yeah, true. So basically, the percentages might probably be correct, but the chart is totally wrong. Yeah, like I said, America, it gives you a lot of information. But this is a little bit of manipulating the data. If you can see here, the axis doesn't start with 0, and therefore this looks like a huge gap. So if the tax cuts expire, so Bush incorporated tax cuts, they want to get rid of it. And they saw, yeah, but look what happens if those cuts are being gone. Look at how many taxes we have to pay. While in essence, it's only 4.6%, which is still a lot if you have to pay it, of course, but it's not as big as this chart shows you. So you always have to think when you're seeing a data visualization or a representation of data, what am I seeing? And always look at the axis, because sometimes they try to manipulate the data, because the data is actually true, but the way it's shown to you gives you a different feeling. This was actually an ad from a banking company, but yeah, there is also a small failure in this one as well. They used the pie chart, and they said is 1/3 of our operating budget goes towards financial aid. And if we have a look at the pie chart, it's not exactly 1/3, so it's 1/4. So either it should be 1/4 up top here, or this line should be should be drawn like that. I'm going too quickly now. So if a bank makes these kind of errors in their ads, maybe it's a good thing to think of another bank to go to. I don't know if you all know Game of Thrones, which was a popular series up until the final season, I guess. Talking about making data accessible and easy to read, you can decide to either read the books, which will be more time consuming. You can watch the series, or you can have a look at this chart, which will exactly show you what happens in the series. So if you read the books, probably it will take you up to 200 hours, something like that. If you watch the series, it will take you 50 hours. Looking at this picture, basically you can understand the entire series within 15 minutes. Who's collaborating with who, and everything like that is shown in this picture. So just to make sure that it's not only data, structured data you can visualize, you can do a visualization on pretty much anything you want. And then you have these graphs. There is a website for it. They give you the strange correlations. So what they do is they check whether there's a correlation between two completely different topics, which in this case is divorce rate and how many margarine is being consumed. So you see there's a drop of the consumption of margarine, and you see that the divorce rate also drops, which is a correlation which is there, but it doesn't mean that it's actually true. But this site is really funny with those kind of things. But especially in the data science part, when you're looking at correlations, so what is the weather? Is it influencing our tourists? These will be the graphs that you can create. And then you can also create two different axes, but always be careful with doing so, because you can manipulate the axis in such a way that the line will always compare to each other. Yeah. Now, some good examples, exactly showing in the picture what needs to be shown. So this is people spending their money, usually what they should be spending. So it's 50% of the time should go to the needs you have, 30% to what you want, and 20% saving. So that's the ideal way of using your salary. But what people are actually spending is more on needs, a little bit less on wants, and they save also less money as they want to. So here it's pretty good show, pretty easily shown the information, and also here with the dotted line it shows what should actually be the case. A waffle chart, I briefly touched that in the beginning, is the usage of a browser. I will try to find a more recent one because I think it changed again a little bit, but I couldn't find it. But what does it show? It shows you every block is basically a percentage, and it shows you in an easy overview what is the one compared to the other. So the total blocks together are all the browsers being used, and the colored one in green are the Internet Explorer, which in 2003 was 88%. Then in 2008 we saw Chrome coming up with a small 3%. And then at the end of 2015, Chrome took over by a lot, and basically Internet Explorer is being used less and less. So this is a waffle chart. I don't see it being used that often by students, but it's also depending on your data, of course. But this is a really nice way to show it in an easy way. Then the final one, it's a heat map. This is regarding all the Avenger comic books being released in over 50 years. And they've shown you how often a superhero encountered the other one. So Iron Man and Captain America, they saw each other the most. And the less the color gets, so it goes from dark red, which is the most, to gray, which is barely see each other. Or grays even, they've never met. So this is an easy way, instead of reading all the comic books, to see the data directly on your screen. But I think it's more fun to read the books. So in conclusion, in the end, it all depends on what kind of data you have and what do you want to show. It's really important who your audience is, and how they will, and in which way they will understand your visualizations. So like I said, if you're talking to the managers in your company and they know the information you give them, you can use words used in that company. Are they unfamiliar with that? Then you always have to explain a bit, like the goals from Messi. If you know Messi and you know football, it's easy to understand. If you don't know football at all, then it's more difficult. Then you're looking at a graph, you say, yeah, I don't know if it's good or not. Always keep in your mind, what is the purpose of your visualization? What do you want to show? What do you want people to remember if they saw your visualization? And especially in the beginning, try to keep it as simple as possible. So we've seen a lot of different visualizations with multiple axes, size of the bubbles. Just in the beginning, when you're starting using data visualization or making your visualizations, try to keep it as easy as possible and then enhance it. It's always good to start small and end big. And one thing, most of the time, I still forget, once you created it, always validate it with your client or the person giving you the assignment, just to check whether all the things you want to show and see with your visualization, that person actually understands it. And in the end, as the same went for Misha, there are a lot of tools also for visualizing data. Just give them a try, see what fits. Especially when you're a student, you can pretty much try every tool which is there, from Tableau, Power BI. Stating that you're a student, you can use it for free. But it's also fine to use Excel, even Paint, or even just a piece of paper and a pen to start off with. So I've practiced it. Terima kasih banyak. Thank you so much for us to do these presentations from me and Misha. Yeah, I hope you enjoyed this lecture. It was a lot of me talking, but I hope you have a clear view now on the topic of visualization, and that you can make use of it during your studies. But also feel free to reach out to me. So in case you have questions or you created a visualization, you can send it to me, and then we can discuss how well it is. And that's it for me. Then we can go back to Burushda.
Okay, thank you, Dan. Unfortunately, we are limited to time, but there's something that I want to note it. I concluded some notes. The first one is the methodology of the CRIPS DM must be done at least more than one iteration, yeah, because you can do it in the first time, for example, that has been shared by Prof. Misha, that we can see from the perspective of visually, and then using the time series analysis, for example, and then using machine learning for answering something that has been done in the previous model. So we can comparing those models. And there are so many tools, but still we have to have a very good interpretation of the data and also of the models. And in terms of CRIPS DM, so data visualization can be done in 3 phases, yeah. In the first data understanding phase, in the modeling phase, and also in the deployment phase. So do you have any question? Do you still have any question in Zoom chat? Bu Jule, ada pertanyaan dari Zoom chat dari YouTube yang mau di
YouTube is still not yet.
Okay, there is no question in YouTube. How about in Zoom chat? Okay, students, do you still have any question? Do you still have any question? Okay, you can privately email all of the guest lecturers here. Once again, I want to thank and highly appreciate it. Apakah Pak Denny ada? Atau Mr. Wendy, are you still here? Before we close our session, Bu Jule bisa take a photo session ya?
Okay.
Okay. Stephen, do you mind to stop your share screen, please?
Yes.
Okay. We will have a photo session, so please turn on your videos, turn on your cameras so we can prepare. And the photo session will lead by Bu Jule, be my guest.
Okay, so ladies and gentlemen, please turn on your camera because we will take a photo together with the speakers. I will guide when I say 1, 2, 3, but we should wait for a moment for all participants to join the camera. Okay, I will guide when I say 1, 2, 3 and say Salam Budi Luhur. Please pause by raise your right hand facing the front of camera screen as Miss Rudah did here. Okay. 1, 2, 3. Salam Budi Luhur. Okay. Next screen. 1, 2, 3. Salam Budi Luhur. Okay. We have 8 page in here, 8 layer or 8 screen. Okay. Please wait a moment. Salam Budi Luhur. Already done, Miss Rudah. Miss Rusdah.
And already? Okay. I think it's the end of our session. Once again, I want to say many thanks to Prof. Misha Bakers and also Mr. Stefan De Nijs for having us today. There are more than 200 students join this room. I hope there's so many advantages that they will obtain from this session. So hopefully this is not the end of our collaboration. So we will talk more with Jorik and also Mr. Paul to create another kind of collaboration, such as international class and also, such as this kind of webinar. Okay. Once again, thank you very much for all your kindly. And I'm sorry, there's already Hazan here. I close the session. Thank you very much once again. Assalamualaikum warahmatullahi wabarakatuh. Salam budi luhur. Bye-bye for now. Terima kasih mahasiswa. Jangan lupa isi link itu tadi ya untuk feedbacknya, untuk perbaikan di sesi berikutnya. Terima kasih banyak. Bye Misha, bye Stefan, bye everybody. Terima kasih Bu Jule dan teman-teman dari Ngampus Application. Terima kasih Bapak Ibu dosen. Terima kasih mahasiswa.